5-minute risk ratios. Let's go. Start with a sample from a population. In this case, we have 200 individuals. And we measure exposure in our sample to a particular risk factor. And in this case, in this sample, we have 100 people who were exposed. That's the exposed group. And we have 100 people who are not exposed, the unexposed group. In a cohort study, we can follow them over time. And then we look at the proportion of cases in each group. In our exposed group, we had 50 cases, or half. In our unexposed group, we had 25 cases, or 25%. So 50% compared to 25% is our risk ratio. 2. We would interpret this as follows. Individuals who were in the exposed group were twice as likely to develop the outcome compared to individuals in the unexposed group. 50% versus 25%. That's all the risk ratio is. Now, you may be asked to calculate it from a 2x2 table. In that case, you would see something like this. Same sample, same numbers. We label the cells in our table as A, B, C, and D. We compare the proportion of cases in the exposed group, in that case it's A over A plus B, and compare that to C over C plus D. And that works out to be 0.5 over 0.25 or 2.00. Again, we would interpret this as individuals who were exposed were twice as likely as individuals who were not exposed to develop the disease in question. Now that we have our point estimate for the risk ratio, we may want a measure of precision, and that would be the confidence interval. So if your instructor is cruel, they may ask you to engage in the following calculation, but if your instructor is nice, you can just ask the computer to give you the confidence interval for the risk ratio. So we'd say that individuals who were exposed were twice as likely to develop a disease, but we would expect the actual risk ratio to be somewhere between 1.35 and 2.96. Now, there are some problems. The first problem is that when the outcome is rare, the risk ratio can be misleading. Here you see the same risk ratio, but a much lower disease prevalence. So rather than 0.5 versus 0.25, we have 0.06452 versus 0.03225. So the relative risk is still 2.00, but you're only doubling a very small risk to begin with if you're exposed. So a better measure for a table like this, or a complementary measure, might be the risk difference. That's simply the risk in the exposed group minus the risk in the unexposed group. And that gives us 0.032. So if we turn this decimal into a percentage, we would say that individuals who were exposed had a risk of a disease that was 3.2% higher than those who were not exposed. And that makes a little more sense with a rare outcome. Another problem may relate from interpretation of the risk ratio when it's less than 1. Let's say we have a risk ratio of 0.40. This might be the case if the risk factor was actually protected. We would interpret this as individuals who were exposed were 0.40 times as likely to develop the disease in question compared to individuals who were not exposed. So exposure actually reduces the risk. Now, someone may interpret this as 40% less likely, but this is 40% as likely. If you want to use less likely, you have to subtract from 1, and we would therefore say that individuals who were exposed were 60% less likely to develop the disease in question. Another problem relates to case control studies, which are good for rare outcomes. Remember, we started with one sample from one population of 200 people. Okay. We then measured exposure and followed them over time and looked at the proportion of cases in each group. But for a case control study, we assemble a group of cases and then we match them to a group of controls. And typically we do 1 to 1, or we can do 2 to 1, or 3 to 1, or 4 to 1. Let's do 2 to 1 in this case. And then we look backward and determine the proportion of exposure in each group. But one thing to remember is that these now represent two different populations. So comparing the rate of cases and exposure in one group is not the same. You're not looking at two groups from the same population. You're looking at two theoretically distinct populations. So in that case, we need to use the odds ratio for case control studies. And of course, we haven't stratified this by any confounders. And so another major limitation is that we haven't controlled for confounder. Thank you for watching.